Welcome back. So this is problem 2 of section 3.1 on web work. So the question is find the absolute and local maximum and minimum values of this function. Notice this function is piecewise defined. First piece is defined from interval 0 to 2 for x. Second piece is defined from 2 to 3 for x. Alright. But notice each of these pieces, they are linear. That is, power of x is simply 1. Power of x is simply 1, right? So these are linear functions. That is, you will get a piece of line from here and you'll get another piece of line from here, which you are going to cut and paste. So here is my graph. The first one is 1 minus x. Y equals 1 minus x. This is a linear function. To graph a line, all you need are 2 points, x-intercept and y-intercept. How do I get y-intercept? That's the easy one. Plug in x equals 0. When x is 0, I get y equals 1. That is 1 point. And the other point, how do I get the x-intercept? Well, notice if x is 1, 1 minus 1 is 0. Alright. Another way to find x-intercept, you plug in y equals 0 and then proceed. So anyway, you got these 2 points. Join the line, join the 2 points and you have a line y equals 1 over x. Likewise, the second one is 2x minus 4. Y equals 2x minus 4. So its line is here. So when x is 0, you get point 0, negative 4. When x is 2, you get the point 2, 0. Yeah, when x is 2, you get y equals 0. So join these 2 points and you get your second line. Now my graph from 0 to 2, x 0 to 2, I need to take this piece. So I'm going to start at 0, 1 and go until 2, negative 1, 0, 1 and 2, negative 1, and from 2 to 3, 2 to 3, I'm going to start at 2, 0 until 3 looks like 2. 2, 0, 3, 2. So this is the graph of fx. It's cut and paste from the first 2 graphs. All right. Notice x is not 2 in the first piece. So in the first piece, when x is 2, I have an open point. It's not a closed point. All the others are equal, so they give me closed points. Okay, so these endpoints are included. So endpoints are included. So this is the only piece, there is an open value there. So x equals 2 would have given me negative 1, but that is open. So this is how you make points open or closed at the ends. All right. Now, looking at this graph, I want to be able to say absolute maximum or absolute minimum. Absolute maximum is over here. 3, 2. Okay. The others are not applicable. So I'm just saying n, 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 n. Now, absolute minimum. The absolute minimum would have been here, but it is not a point on my graph. It's an open point. So there is no absolute minimum. So they are all n. All right. Now, local maximum. Local maximum is here and here. Okay. But my web work is unable to accept it. So in reality, n is wrong. Local maximum, there is a local maximum here and a local maximum here. All right. So it should be 0, 1 and 3, 2. You understand? Local maximum. This is a maximum locally and this is another maximum locally. Okay. But I have checked these answers and web work doesn't seem to accept these two. Web work is wrong. I'm letting you know. Local minimum. The only 2 minima that would have worked was going to be this. This wouldn't work. Notice, while this is smaller from the right, To the left of it, you have smaller points, lower points. So this will not count for a local minimum. This would have counted, but this is not a point on our graph. So there are no local minima. All right. Submitting answers, let me remind you, this is correct even though Weber complains. All right. So I'll stop here for now.